started talking about how to manage large assemblies. So today we're going to talk about part 2. So if we do a quick recap, this is actually what we started talking last time around. So we touched on defining a large assembly, the activities SOLIDWORKS has to do when it opens and updates an assembly, and also we talked about best practices to improve the file open time. So today we're going to focus on the second half of this discussion, which is how to improve the update times in assemblies, do the same thing in drawings, and also touch on hardware. So if you have any questions during the presentation, it's going to be, I have to say upfront, it's going to be a lot of information. So I might not have time to answer any questions, but if you have any, put them down in the questions panel in the GoToWebinar interface, and I'll reply offline after the session. So let's get to it. So first of all, let's talk about improving update times. So let's go through this. Now, first statement about update times, either in assemblies or drawings, is that you have to be knowledgeable in the fact that any change you make to any part or component or any part of a component will in turn draw a update at the assembly and eventually at the drawing stage as well to reflect the change. Now let's talk about how we can minimize, avoid, or help with that process. So first of all, first thing I want to touch on is limit in-context features. So for example, if I compare two designs, so first I get a component, I just pluck it out of my library, put it into my assembly. There's no in-context features in that part. That means that if I do a change at the assembly level, I don't need to rebuild any of the features in the part. And to some cases, when I open an assembly, I won't even have to load the features inside the part. So if you use lightweight, for example, that's a good example. That's a typical case. Now, on the opposite hand, I'm designing a part in the context of the assembly, so I have in-context features. So by contrast, everything I change at the assembly level will prompt a rebuild at the part level, but you also have to consider any child features of that. So for example, if there's a mate, attached to that feature, at the part level, that needs to be rebuilt as well. So that can actually drill down, a couple things. So one way, and I mean, I have to say, I really love in-context features. You just have to use it wisely. And when we're talking about large assemblies, here's a trick you can use to manage those in-context relationships much easier at the assembly level. And we oftentimes refer to that as a skeleton sketch method. So the idea is fairly simple. So first of all, I got my top assembly. And rather than putting my, modeling parts and subassemblies and referencing the in-context, left and right between everything, I'm going to, at the top assembly level, insert either an assembly sketch, or oftentimes it's going to be like a base part that has a sketch in it. And then I'm going to refer or make my relationships to that single point of contact. So it's just an easier way to manage the in-context relationships, and there's a few benefits to that. First of all, when you're designing and the model, the assembly is changing quite a bit, it's much easier to propagate changes down through that use. The other thing too is, when you switch from a very design-oriented phase where you should do a lot of changes to the model itself, and when you change to a phase where it's more about detailing, so typically that happens when you start actually doing the 2D drawings, the detailed drawings. Oftentimes when you go to that stage, the 3D model is kind of set, not maybe not set in stone, there's going to be changes to it, but the overall shape, overall design of the 3D model usually is going to be set by that time. So what I'll say is, at that stage, go ahead and lock references. So the references are still there, but they're locked, meaning that when you do a change, it doesn't, or when you switch between parts, assemblies, sub-assemblies, it doesn't prompt a rebuild all the time. So that can actually speed up your assemblies quite a bit. I like to use lock simply because if there's a revision, I need to actually do a change at the top level. I can unlock to propagate the changes. The other thing with lock is that you can lock it, do many changes, right? And then unlock it, propagate all the changes at once, and then lock it back up. So as you're working, it speeds up, while working into the process. You can also use break, more useful in the case where you want to create a second design based on something existing, but that won't have any relationships with the first one. You could use break. You just need to know that once it's broken, right? When you lock, you can unlock it, so it's kind of a toggle. So that's a method you can use to do large design with in-context relationships to help you manage all those relationships. Another tip: using rigid subassemblies, and I'm going to emphasize the word rigid subassemblies. So here's a typical concept, typical assembly. I got my top level assembly. In that top level assembly, I'm putting 3 parts. Each of the parts has 3 mates to define them. So that means that at the top level assembly, it has to calculate 9 different mates. It has to solve 9 different mates. Makes a ton of sense, right? Just by inserting a rigid subassembly in my top assembly level and putting all the same 3 parts, although I still have 9 mates to solve at the subassembly level, the top assembly level just needs to solve 3, the 3 that's defining the subassembly. So, I mean, for a lot of you, that's going to be common sense, but once you think about the implications of doing subassemblies, that's where on a large assembly, it just makes a whole lot of sense at that stage. Now, the idea with that process using a rigid subassemblies, and again, I'm going to underline the word rigid, is that in a rigid subassembly, SOLIDWORKS sees that subassembly like a rigid body. So that's why you can simply use 3 mates to fully define a subassembly. SOLIDWORKS, once it sees a subassembly, doesn't look any further than that for mates. It just solves the 3 mates at the subassembly level. It simplifies the mating structure at the top level. It improves performances, but also makes it a lot easier for troubleshooting. So again, be knowledgeable about how to create your subassemblies, your rigid subassemblies. Now, by contrast, flexible subassemblies are great. You have to be careful though. I'm going to take this very same example. I got my top assembly, rigid subassembly, 3 parts, 3 mates each. We just went through that, 3 mates to solve. Let's turn that subassembly from rigid to flexible, see what happens. Same structure, exactly same structure, top assembly. This time I got a flexible subassembly with 3 mates, and I've got my 3 parts. Now, all of a sudden, my top assembly needs to solve 12 mates, not just the 3 at the part level, the 9, I should say, at the part level, but also has to solve the 3 at the subassembly level. Because for SOLIDWORKS, when it sees a flexible subassembly, it actually goes into that subassembly to solve all the mates of that subassembly. And imagine there's another subassembly in that one that's also flexible. It has to go into that one too. So you have to be really careful. I mean, flexible subassemblies are awesome. You just have to understand what's the implication of using them. So here's an example. I've got this top level assembly, and if you look closely, both arms, left and right, are actually the same subassembly. And you see there's like a bracket on top. The orientation is different. One is horizontal, the other one's vertical. So let's take a look at that example. So for example, if I put both subassemblies flexible, at the top level, I have to solve 42 mates. If I simply turn my subassemblies from flexible to rigid, I just need to solve 18 mates now, more than half less. So that makes a huge impact. That's not a big assembly, not very large assembly, but imagine you're into the thousands, tens of thousands of parts. That will have a big impact. So a couple of ways you can kind of manage that a little bit better. So first of all, you can turn your subassemblies flexible just so you can position them correctly. Once they're positioned, lock them in place if you want and turn them back into a rigid subassembly. So going from flexible subassembly to rigid is just like a radio button. It's a toggle switch. So it's very easy to do. Another method you can also use is at the subassembly level, create two configurations like open, close, position 1, position 2, whatever you want to call them, and use control the position via configurations instead using rigid subassemblies. Now, some of you might say, well, I'm creating more configurations, my model's getting, putting more information into my model, is that impacting the performance? Not really compared to flexible subassemblies, because internally, that's transparent for the user, but internally, when you're using a flexible subassembly and doing two positions like you see on the screen here, internally SOLIDWORKS is actually creating configurations, so it's able to show you both positions. So it's not worse than using flexible subassemblies to create configuration. So that's a valuable method of managing those. So next up, avoid mating to pattern instances and to assembly features. And there's a few reasons why. Actually, let's talk about some examples for start. I've got an assembly, and at the assembly level, I'm doing a whole feature, and maybe in that whole feature, at the assembly level, I'm mating a part. So that's an example. Second example, creating a assembly plane or axis and defining that by a face of a component, and maybe mating to that plane. Or a third example that we'll see, from time to time, is that you've got a pattern inside of an assembly, and you're mating to one of the patterned instances. Those are things you want to avoid as much as possible. I understand that sometimes you have to do it, but try to avoid them. Here's why. SOLIDWORKS is actually optimized to solve all mates at the same time. That's how SOLIDWORKS is built. When it can't, it will follow the assembly tree order, right? So depending on if you create assembly features, it'll just follow the tree. Now, when you're creating or when you're mating to pattern instances or to assembly features, you're creating a order dependency, meaning that it can't do everything at once like SOLIDWORKS is built to do. It has to do things in order, and because of that, it rather than being in parallel, it's now becoming a sequential operation. So here's an example. Here's the process. So I've got, let's say, two plates. I'm doing a hole in the assembly, at the assembly level, putting a bolt inside that hole. First of all, it has to solve the mates of the two plates, right? Then it has to update the position of those two plates and the feature. And if I'm putting a mate inside of that, it has to solve that mate inside of that hole that's defined by the position of the plate. So you see here, there's an order, and it can't really solve the position of the bolt before it solves the position of the plates, where the hole is and where the bolt is in the hole. So it just creates an order dependency that will make solving those constraints longer. So you want to avoid that as much as possible. And then there's just options. One of them is to suspend the automatic rebuild. In your system options, it's part of the large assembly mode settings. Now you have to be careful. This is really useful for in-context features. And a good example is routing assemblies, because by the nature of routing assemblies, they use a lot of in-context relationships, in-context sketches, but it won't affect, across the board. So it won't have any effect on mates and display updates as well. Now, there is a setting you can use to actually prevent the update of display when you're switching from window to window. So let's say I do a change on a part, I go back to the assembly. By default, the assembly is going to rebuild. There's actually an option that you can prevent that update until you actually click the update button. So on large assemblies, that also makes a lot of sense to use. Now, again, talking about the suspend automatic rebuild, if the in-context parts need to be rebuilt, even though it won't rebuild, you'll see a little, green red light into the tree. That's actually just a prompt telling you that it would need a rebuild. It's just waiting on you for you to actually rebuild it manually. And it allows you to do multiple changes at that level and just update once, rather than having to wait every time there's a change you do. So you can do 10 different changes and then hit update once and do everything at once. Also, to help improve on the assembly performance, one way to do that is actually to reduce the graphical demands. Because every time you do a change, SOLIDWORKS has to paint that change if you want on the screen. If you reduce the information it has to paint, you're better off, better performance. So here's a few options. First of all, the image quality in your document properties. So have to be careful. By default, usually they're kind of set midway. If you're dealing with large assemblies, you might want to dial that back down to a low setting. And also, go and take a look at your templates. When you start a new part, it asks you for a template. You start a new assembly, asks you for a template. Go in and check those templates. So you could actually create templates with, low quality and medium quality or resolution, however you want it. But, do that at the template level so you don't have to go in each and every time to adjust this for each and every part. It doesn't make sense. So do it as a template. That's easier to do it there. Also, when you're working, I'm going to kind of drill down through a list of options. Hidden line remove, work in shaded versus hidden line visible or hidden line remove. Turn off real view. Other things you might want to use is try to limit transparency at the assembly level. That takes a lot of resource to paint. Also, disable or hide everything from the view menu, and I'm talking about reference planes, axes, temporary axes, curves, sketches, annotations, whatnot. So you can hide all of that information, less thing on the screen to paint. Also, the level of detail into the performance settings. So if you want to have something really snappy, when you zoom, pan, rotate, you can dial it down to a less setting, which is faster. Disable verification on rebuild. So there's a lot of things to do, and you're gonna say, hey, it doesn't make sense for me to every time I work in SOLIDWORKS to go in and switch these automatically one by one. So that's why we actually created the large assembly mode, is that you can set much of those or all of those in the large assembly mode, and just with a flick of a switch, so you can enable disable large assembly mode from the assembly toolbar. So just clicking on that, it just sets a number of those settings automatically for you. And there's also a setting inside of SOLIDWORKS. When you open an assembly, there's a threshold. So if your assembly is more than X parts, it will automatically go into large assembly mode. So that's a good thing to be knowledgeable about. Also, with regards to graphical demands, there's a few other options not controlled by large assembly mode you might want to take a look at. So for example, anti-aliasing, highlight all edges, and dynamic highlight. That's from display, system options display. dialog. So these three options you see right there. So you might want to disable those. Another option you might want to take a look at is Feature Manager Dynamic Highlight. Also, that will help in large assembly when you're navigating in the tree and in the screen. Less things to paint again on the screen. So another tool we can use, and I spoke about this tool earlier in my first session. We're going to review it here because the performance evaluation helps you find bottlenecks in different levels. So when in July when I did part one, I talked about this tool to find parts that are long to rebuild. The same tool can show you parts that are hard to display and takes time to display and even open. So let's take a quick look. So for example, here's the assembly. If you don't remember, I'll just play this. So from the toolbar, performance evaluation. So that tool was completely overhauled in 2018. Shows a lot more information, much easier to decipher all that information. Also shows you the image quality, and that's a direct relationship with your graphics quality or performance. Now, the other thing too is that from here you can launch the assembly visualization, and then you can filter based on different rules. So for example, here I'm showing the number of graphics triangle, meaning parts that are easy versus hard to display, or easy versus hard or long to display. So here there's a part in red. There's a lot of graphical entity. I switch configuration. I've got a simplified version, and all of a sudden this is just simpler to display on the screen. So the assembly visualization tool is really great combined with the performance verification. So we spoke about already, we kind of covered a couple things with regards to assemblies. Now let's talk about 2D drawings, because most of the times you have a large assembly, probably that's going to end up in a drawing somewhere. So let's talk about drawings. So first things first, use hidden line remove or shaded views as you can. Now, if we kind of break down the different type of view display by, let's say, cost of computing, it would look something like this. So first of all, I've got a part that's a wireframe. That costs actually in computing or display, it actually costs a lot of money, let's say, to SOLIDWORKS, because there's a lot of things to paint on the screen. By comparison, a view with hidden line remove is quote unquote cheaper to display on the screen. It does take time to calculate, but the benefit versus versus the calculation actually on the display, when I'm really talking about zoom and pan in drawings, that's cheaper than the two previous. And one that's actually even cheaper than that is shaded with no edges. So you might be wondering, why the heck would I want to do 2D drawings in shaded, no edges? That's not, drawings are basically lines, right? Actually, for some cases, it actually might make a lot of sense. Here's a few examples. So I've got this assembly. As you can see, it's a simple, it's a very simple, well, the assembly itself, few hundred parts, but the view itself, isometric view bill of material, as you'll notice, there's no edges. It's just a shaded view. Now, if you want to print it, you're probably not going to print that in color. It doesn't make sense. You want to have the lines, yes. But what if you're going to distribute that electronically via e-drawings, for example? Even though your 2D drawing inside of SOLIDWORKS might just be a shaded no edge drawing, when you're going to publish it to e-drawing, e-drawing is going to have the edge information. So you can control that in e-drawing. So for example, like I said, if you're distributing that via email, for example, you might not need to create the edge display in your 2D drawing. Now, here's probably a better use case than that. Typically when you go ahead and create a 2D drawing, is that eventually you're going to print it. If you're creating 2D drawings and not printing them, I would argue, why are you doing 2D drawings in the first place? But here's another example. You can use shaded views while you're creating your drawings just to get more performance out of your drawings. So for example, this is actually a clutch assembly. I think it has about 50, 60 parts in it, 3 section views. So I'm creating those views in shaded, no edges, because it's way faster to do it. And then as I'm starting to detail that drawing, I'm going to switch my views to a regular hidden line remove view, and then start adding dimensions, my notes, my whatever I need to put in there. And if I compare the two, the one that's now behind, that's shaded no edges, versus the one that's hidden line remove, the one in the back rebuilds twice as fast as the one in the front. So it's just a process, right? So as you're creating your drawings, start putting the views in shaded no edges, and you can set that by default. And then when you're ready to start the detailing, dimensions, and all that information, just flip them on to hidden line remove when you need it. It's just going to make the whole drawings much faster to work with. Also, one thing you want to be careful of is simplified versions of models. Again, so I spoke about that when we were talking about assemblies, to create simplified versions on my first webinar of my part 1. And basically, because everything you do in assembly to gain performances is going to reflect in drawings 99% of the time. So if you take the time to simplify a part, that's going to make your assembly faster. And if your assemblies are faster, your drawings are going to be faster in the update time. I'm talking when you're doing a rebuild. So everything in drawings, you can trace that back, has an effect, way back down to when you started parts. And that's something I mentioned in my first webinar. Be especially careful with downloaded parts that you put into your library. It does make sense. You will see the benefits of, let's say I need a motor or a gearbox, and I download my file from the web. Before you put it into the library and have everyone else use it, just be really careful and clean it up, because that motor, that gearbox is going to end up in 10 assemblies. Those 10 assemblies going to end up in 10 drawings. If that part is not simple or is not simplified, it's going to affect all 10 assemblies, all 10 drawings. So it really has a domino effect. So be careful with that. Also, section views. So again, as a matter of cost, let's say, section views in terms of calculation are the views that are the most intensive to calculate. So, and here's why. So you want to, consider other ways when possible. I'm going to say when possible. I understand it's not always possible, because here's what SOLIDWORKS has to do when you create a section view. When you create a section view in the drawing, it actually has to go, we don't really see it as a user, but SOLIDWORKS on the back end is creating a cut at the assembly level, so basically just a cut at the assembly level. It has to generate the view for that cut, and then it has to, on top of that, paint the hatching. So it's really like a 3-step process. It has to cut the assembly, generate the view of the cut assembly, and then paint the hatching. And considering that there's a few options just with hatching, hatching the toolbox components or not, change the scale, automatically adjust the scale of the hatching and the orientation. There's a lot of calculation that has to be done to create that section view. Now, the thing is, also remember, if there's a change at the model, everything has to be done again, right? So every time there's a model update, you have to do it over again. So it's going to be cheaper in terms of calculation, rather than making a section view, maybe just do a regular view and hide components, like hide a cover, hide a part, so we can see inside when you can. I understand it's not always feasible, possible, but when you can, try to avoid section views, especially on large drawing assemblies. Also, there's a few options you want to take a look at. So for example, when you look into the system options, drawings performance, the top two options is going to really help you work inside of drawings. So disable the contents while dragging a view, and also disable the auto update when you're opening a drawing. Just getting faster response from the system when you're working inside those drawings. There's another setting right below, and I mentioned this to strategically turn off. So you don't necessarily want to turn it off. It might make sense in some cases, and some others it won't make sense. Is to turn off the tessellated data. So why do I say strategically? It is because if you're planning on viewing the SOLIDWORKS drawings with eDrawings, you use eDrawings as a viewer, or if you have PDM, you do have the viewer on the bottom half of the window, it does need tessellated data to show drawing information using eDrawings. So like I said, if you're not using eDrawings at all, and you're not using PDM at all, you might want to turn it off. It won't affect much. If you're using eDrawings to view files, or if you have PDM, you might want to turn this option off for a time while you're making your drawing. You're going to see some benefits when you save, and probably when your drawing is complete, you can turn it back on. That's actually a system setting. But you turn it back on, save the drawing, and then the tessellated data is saved with the drawing. So you have to be strategic about that one. Also, the performance evaluation that we just saw just minutes ago for assemblies will also work with drawings. So when you do that, when you use the performance evaluation in a drawing, you can actually see drawing information. And that's actually, that screen capture is from a drawing, not a big one, I'll admit, but it shows the open time for the drawing, the total rebuild time for the drawing. It also shows information for views, so the time it takes to rebuild the views, even if there are sketch entities, if there's reference files. So it actually shows a lot of things. So you can see which pages of your drawing are the longest to rebuild and which views inside those pages might be a bottleneck. So one tip here, I didn't put it in writing, but one tip you can use for views that take a long time to rebuild is that you can simply hide them temporarily. So you create your view. Once you're done detailing that view, you hide it. And before you print the drawing, you turn it back on. So you're going to save on the rebuild time. One thing I want to mention too, the little the view palette to the right-hand side of SOLIDWORKS that has the view previews. You can simply drag and drop to create your views. SOLIDWORKS needs to regenerate that. And actually, if you look at my example here, that's actually what it takes the longest time to do. So if you see that happening, go to the palette view, the view palette, I should say, and there's a red X where you can actually turn off completely the rebuilding of those the little view icons. So that's going to save on your assembly rebuild time, or drawing rebuild time, I should say. And also just be strategic. Now this is going to be just so much common sense. Probably most of you don't need to know me to remind you that. But when you need to do some changes, do multiple changes. Go to your assembly, change everything you need to change, and then just update your drawings once, right? So it's just a ton of common sense. Just be careful when you do it. The other thing I want to mention too is there's a lot of questions with regards to draft and quality views. Some people have tried draft views. They say it's actually longer than high quality views. So here's kind of the lowdown on draft versus high quality views. So for example, start with high quality. High quality views, they are longer to create and longer to rebuild. On the opposite hand, they're faster to save, when you compare them with the draft quality views. So the draft quality views will be faster to create and rebuild, but longer to save. So, and that's true for most cases, not all cases, but it's going to be true for the vast majority. So draft quality, faster to create, longer to save, opposite for the high quality. So knowing that, one thing you can do is when you start creating your drawing views, create them using the draft quality just to do the layout of your drawing page. And as you start detailing, adding the dimensions, the annotations, all that information, turn them on as you go to a high quality view. So that's something you can do. The other thing too, if you have a lot of drawings to do, remember that the task scheduler actually has a task to convert from draft to high quality. So the task scheduler can help you get things done in a batch much easier. Next thing. So we're talking about improving drawing update time, yes. And then I'm saying to improve that, improve your assembly update time. Like I said before, both of them are in direct correlation. If your assemblies are long to rebuild, your drawings will be long to rebuild. If your drawings are long to rebuild, 99% of the time it's because your assemblies are long to rebuild. There's few cases where assemblies are long or drawings are long to rebuild, but not assemblies, and that's really rare, but typically both of them go together. So, I spoke about the domino effect a little earlier on. Yeah, oftentimes the best way to speed up drawing is to actually speed up the assemblies that you use into your drawing. So be careful of that, right? So everything you do at the assembly level, you'll just see benefits at the drawing level later on. And that kind of covers, the tips I wanted to talk about drawings. So we still have, 20 minutes to go. So we're going to talk about hardware. Cover the basics with hardware. So first of all, RAM memory. Really, you just want to have enough to avoid paging. Paging is when the system needs memory to run application, and when it runs out of the available RAM memory, it's using disk as a place to put some memory. So it's starting to page the disk. That's what we call paging. So you want to every time avoid starting paging because when that starts to happen, the performance of the whole system just grinds to a halt. It just, really digs down. So one way to verify that, open the applications you work through the day. Like I work in SOLIDWORKS, but I have, Outlook always running, and I have, I'm working on Word, Excel, whatnot. So open the typical application you have during the day, launch SOLIDWORKS, open up a large assembly, and then look at the task manager and see where your memory is at. So on my system, I got 32 gigs of RAM. I opened up that assembly with a couple other things. I still have plenty available. So my system is good to support that type of assembly. So do the same with your system and watch memory, right? So it's very easy to do. Now, a couple of considerations you want to consider if you're using simulation tools like FEA or CFD, fluid dynamics or simulation analysis. Those applications tend to use a lot of memory. They can be memory hogs. So I do have a lot of RAM on my system. You saw 32 gigs. But if I'm running a complicated simulation, I'm going to need that memory, right? So you have to be careful about those applications that might be using a lot of that memory. So, and to be honest, memory is the cheapest thing you can put into a computer to improve its performance if you need it. A little harder for laptops, but for, towers, desktop computers, it just costs nothing now, memory. Next thing is CPU. And rule of thumb, the faster the better for most operations. For most operations, the faster CPU is the better. For the last, probably 5 years, 5-10 years, the CPU processing power and speed has pretty much plateaued. There's not a lot of increments in performance in CPU that we were seeing over 10 years ago. But the faster is still the better for most operations. But there's some operation that doesn't rely as much on CPU. So for example, open time, they're going to be more dependent on disk and network speed than they will be on CPU. Typical for 8 processors or cores is going to be common, is going to be the norm. Do you need more? You might need more, but in extreme cases, in my opinion. If you're using if you're doing photo view, a lot of rendering, it might be worth it. If you're using simulation, again, the simulation tool can be resource intensive, both CPU and RAM. So if you're doing a lot of simulation, it might make sense to add in additional CPUs and pay extra money to get a little that faster CPU. But for most cases, a good CPU is going to be just fine. And again, additional CPU, additional core will affect on open times a little. So if that's the bottleneck, adding CPUs or faster CPU won't solve it really. Video card. So the other main component, so there's 3 main components with a computer. I didn't mention this, but obviously it's part of it too. But video card, the one critical thing, you have to use a video card and a driver that's certified for SOLIDWORKS. So that's really the first thing you have to do. Now you have to be careful because drivers, sometimes people will update their drivers and get to a newer driver than the one that SOLIDWORKS certifies. No, take the one that SOLIDWORKS certifies because we test those. And sometimes Windows will actually update your drivers for you. So you have to disable Windows from tampering with your driver version. You really want to get the one that we certify. It's easier for troubleshooting because that's the one we tested, and performance-wise as well. The other thing too is with regards to video cards, there's a lot of range. Usually mid-high range video card. Don't go to the extreme low end. Don't go to the extreme high end. It's not worth it up until now. I'm going to get back on that. But typically, the typical cards are going to be your NVIDIA Quadros, AMD FirePro, Intel HD graphics. That's you'll see those more if you buy like a Surface Book, a Microsoft Surface Book. It's going to be an Intel graphics card in it. But up to SOLIDWORKS 2018, you don't really need to go to that really high-end card. Let me show you why. So, and I'm going to, again, specify this as 2018 and prior. So when you look at graphics card, there's usually 3 to 4 level of graphics card. There's that really low-end graphics card, but don't go there. They don't have enough memory to run SOLIDWORKS well, and they just become obsolete too quickly. So it's not even worth, even though they're cheap, it's not even worth it. Our suggestion for up to SOLIDWORKS 2018 is a good mid-range to high-range video card, because as you're using those cards, SOLIDWORKS can take benefit or take the advantage of those cards. But up until SOLIDWORKS 2018, people were asking, should I buy that really huge graphics card with gazillion dollars price tag to it? Up until now, it wasn't really worth it, because SOLIDWORKS could not tap into the extra power that the GPU had. So it was great if you're doing renderings with Visualize, because Visualize could scale the power of the graphics card, but not SOLIDWORKS. So that's up until 2018. And I'm going to actually talk a little bit about 2019, because there's a lot of developments in 2019. So up until today, up until SOLIDWORKS 2018 included, SOLIDWORKS, when it needed to do something graphically, it would actually send all of the information to the CPU, and the CPU was responsible to calculate the display and it would just send the information to the GPU or the video card and paint it. So it was a very serial process, and much of it was done by the CPU. In 2019, we're re-architecturing the whole graphics engine, and it's the biggest re-architecture of the graphics engine since the start of SOLIDWORKS, so it's a pretty big deal. And basically what we're doing now is that we can send information to both the CPU and the GPU at the same time, so there's two benefits there. We can offload much of the calculation from the CPU, so the CPU does have more room to do more things, and we can offload that to the GPU and then display that information. And if you're, you look at technology in the last couple of years, the GPUs, the video cards have gone so much more powerful in the last couple of years. It's really amazing with, all the VR technology and all that stuff. So if you look at, 2019 going forward, and we look at the same performance graph I kind of illustrated earlier, again, you don't want to have a low-end card, but even if you have the exact same machine, just by going from 18 to 19, you're going to see a increase in a boost in performance, because now, like I said, 2019 can send information to the GPU simultaneously and to the CPU. So the graphics are rendered quicker. The other benefit with 2019 is that now, if you invest in that, ultra high-end video card, now we're going to be able to tap into the extra horsepower that you have in the GPU. Prior, up to 2018, we couldn't really get that extra performance out of a high-end, ultra high-end video card. In 2019, we can. Let me show you a quick example of 2019 right now. So here we see a huge assembly. It's a telescope. You can see the size of this thing, just by the little levels down here. That's 2018 right now, but it's 2018 in large assembly mode. And when you turn on large assembly mode, you give a lot away. So, the display apps, to simplify the display a lot, if I turn off large assembly mode, see how it becomes, chalky, it's blocky. Everything I do is kind of, stuttering a little bit. By comparison, that's 2019 without large assembly mode enabled. See how much it's faster? If we put them side by side, it just makes it's even more. We can see it even more now. 2018, so same model, same computer, same graphics card, and same level of display to both screens, and you can just see that SOLIDWORKS 2019 is just snappier. It's just easier. It's just smoother. You can do things just a lot quicker, especially with those large assemblies in 2019 compared to 2018. And that's because, like I said, we're utilizing much more efficiently graphics card engine or the GPU compared to what we could before. So a few notes with regards to that. To have full benefit of the extra, processing power of the graphics in 2019, you have to make sure that your card supports OpenGL 4.5. So that's the new, what we call the performance pipeline requirement, the new method of calculating to use the GPU much more efficiently. So you have to support, your graphics card has to support OpenGL 4.5. And we do recommend, it's not specific to NVIDIA cards, this will work on other type of cards, but we do recommend the latest generations of NVIDIA's, the Kepler, Maxwell, Pascal, and Volta. So those are the cards that work better under those, using the new performance pipeline. So this is really a big deal in 2019. There's a lot of performance enhancements. That's one of them. The biggest one, it's a huge overhaul of the architecture, and it shows. I think most people will be very pleased with that, especially with large assemblies. So as we wrap things up, we talked about a lot of different things. Our first session was the first three, so we defined a large assembly. We talked about activities and how to improve open time. We got that recorded. I can send you the link. I'll show you the links where to get those videos. This session is being recorded as well, and we covered how to improve update times in assemblies, update times in drawings, and we touch on hardware. So just to kind of wrap things up, we just released SOLIDWORKS 2019 yesterday. It's currently in pre-release, so officially SP0 is going to be coming out in October. But there's more than just the performance, the graphics performance. A few tools dedicated for large assemblies. There's enhancements in the large design review mode. So now we can add, delete, and move components. We can add, delete, edit mates. We can change configurations, and we can save edits in large design review. So we can just do a lot more in large design review than what we used to. Another tool focused on large assembly management and design is the silhouette defeature. So we had the defeature before, but now we're adding a new method of defeaturing using the silhouette displayer, if you want, of that model. So you can massively defeature the big assemblies. So it allows you to create simplified parts from the silhouette outline. You can also select identical components. And there's a link, associative link between the defeaturing model and the original one. So if there's a change, it can be updated both ways. And there's just so much more, right? So there's, over 200 more enhancements in 2019. So there's just a lot with 2019. I encourage you to take a look at the website. The content's gone live yesterday. So, but there's already probably like maybe a dozen or more videos on different things in 2019, and also the launch event. So our resellers are going to start the launch event in October. So stay tuned. Go in and get in contact with your reseller so you can check the new events. Check the new events, check the new features, and go to those reseller events. As I said before, here's the link. So we record all of our sessions. The link's there. If you don't have time to grab a picture of that, just send me an email. In any case, tomorrow you'll get an automated email with the link for the recording if you want to watch it back. So on that, I'm going to wrap it up. If you have any questions, just feel free to shoot me an email, and I hope I'll see you soon. Thank you, everyone.